Hey guys, welcome to lecture 1. In this video, we will be covering all about the basics about sets. So let's start with a very basic understanding of what is a set. A set, in very simple words, is a collection of objects where order and multiplicity don't matter. These objects are called elements or members of the set. So I'll give a very basic example of a set. For example, we can have a set of alphabets. For example, A is equal to A, B, C, D, and E. For example, this is a set of the first 5 alphabets, right? A to E. Now, this is a collection of objects. As you can see, it's basically a collection. Now, it doesn't really matter that its collection has a specific type. It could be anything. It could be a collection of maybe cars with all the alphabets, with all the numbers. So it doesn't really have a unique property that it has to be something specific. So it's basically a collection where order and multiplicity don't matter. I'll first try to explain this statement and then I'll move on to explaining the order and multiplicity part. These objects are basically called the elements or members of the set. In very simple words, A over here would be an element of the set, right? Similarly, B, C, D, and E. All of them would basically be the elements of the set A, right? I hope this statement is very clear. Now, let's try to understand what is the meaning of order and multiplicity don't matter. This is a very important statement to understand. The meaning of order is that I can keep the elements in any way I want and it would still wouldn't matter. I'll try to explain it with a very simple example. So consider I have a set A, B, C. Order does not matter means that in this set itself, I can arrange it as B, C, A, or I can write it as B, A, C. All these sets would still be the same set, which is they're all equal to each other, right? So it doesn't really matter in what order I place these elements, the set would still remain the same. Now moving on to multiplicity part, the point is it doesn't really matter how many times a single element or a distinct element appears in the set, it would still be counted as appearing only once in the set. What my point is that, for example, if I have this set over here, it has 3 A's, 1 B, and 1 C. This would again simply be the same as A, B, and C. And this would again be the same as A, C, B. Point is that multiplicity and the order, it doesn't really matter in sets. So they can be arranged in any way possible. This is a very important thing to understand about the very basics of sets. Right? So I hope you have a good understanding about what is a set and how we represent it. Moving on, let's try to understand set notations. So thing is, in mathematics, the point is that we need to have denotions. We need to have some small way to denote something so that it's easier to understand. So for example, we don't simply use entire English sentences to represent statements. We use small words such as a plus sign or a minus sign to represent mathematics, right? In same way, we also have some denotions for sets as well. I'll start with a very basic one. Now, in order to say an element belongs to a set, so for example, if I have the set A, which is equal to A, B, C. Now, in order to say that A is an element of the set, I use this following notation. This symbol is used to represent that A is an element of the set A. In very simple words, so as you can see that we have this big English sentence over here and I've reduced it down to this simple 3 words, right? So this is very important thing to understand. This is just a very basic thing. Again, if I give you another example, B is also an element of A and C is also an element of A. So this basically means is element of. So I hope you have a good understanding about the set donation. It's very important to understand and don't forget it. It's going to be useful in the future as well. Moving on, let's try to understand what is an empty set. Now, it might seem like a very simple word. Empty set would just be these empty braces, which is covered with this, and you would be correct, right? Basically, this is the empty set. We can also represent this as this symbol. So these two are basically the same and they represent the empty set. It might seem like it has absolutely no use in sets, and why do we need it? But as we move on further in set operations and to more complicated parts of set operations, you'll understand that this is actually a very important part, right? So keep this in mind. I'll also move on to a bit more complicated understanding about the empty set as well. But for this video, try to understand the very basic thing, which is that this and this are not equal to each other. This is an empty set, while this is a set containing the empty set. So there's a difference to it. If you don't understand it, pause this video again and go back and try to understand it one more time, right? For now, this would be a good understanding about what is the empty set, right? Moving on, let's try to understand another very important thing to understand, which is the finite and the infinite sets. So from the words, it might be clear that finite, meaning they have a limited number of elements inside it, which we can count. An infinite set would be something in which we cannot really count the number of elements in it. I'll try to give a very basic examples of both of them. So example of finite set would be 1, 2, 3, and 4. This is just a very simple example of a finite set, right? A set containing the numbers from 1 to 4. Similarly, we can have infinite sets which have infinite number of elements. Now, a very basic examples of infinite sets would be set of all real numbers. Same way it could be set of all integers. So as we know that these sets, they basically go beyond a certain point, right? So for example, the set of integers goes from negative infinity to positive infinity, and same is with the set of real numbers as well. So basically, we know that they have the curly braces, and we know there's a collection of objects in it, but we just don't know where it ends and where those curly braces are going to occur on either side of the set, right? So this is an empty set. So we have infinite sets. We will go deep in infinite sets as well. And finite sets are in very simple, just finite sets, right? So they don't really have infinite number of elements. We can count whatever we have inside it. Now, understanding counting comes the concept of cardinality of a set. Point is, when it comes to infinite sets, we need to understand what is their cardinality. Cardinality basically means number of distinct elements in a set. It's very important to understand that it's the number of distinct elements in a set, which is the unique elements in a set, right? I'll just give a very basic example to understand what is the cardinality of a set. So for example, I have this set A, which is A, B, and C. The cardinality of A, which is, we represent it with this symbol. So basically 2 lines on either side and the name of the set in the middle. So the cardinality of this set would simply be 3. Why? Because we have 3 distinct elements inside this set, which is A, B, and C. So I hope you guys understand it. Moving on, we have understood cardinality of the set. We have understood set notation, empty sets, finite, and cardinality. Let's try to understand that there are actually 2 different ways we can denote sets, right? So one simple way would be the one that you've been noticing so far, that we basically use just the curly braces. We write all the elements inside it and we just cover it, right? So this is the notation that we have done so far in this video. But we also have another notation. So this notation that we have been using so far is called the roster notation. So roster notation would be this would be the roster notation, right? I've given this basic understanding or definition of it. So if you want to pause this video, you can take a look at it once again. So roster notation would be this. So example 1, 2, 3. This would be a simple roster notation. And moving on, let's try to understand what is the set builder notation. Now the point is that when it comes to certain sets which are infinite, we had to find a way to represent them as well, right? So we came up with this very, I would say, genius kind of way, which is called the set builder notation. In very simple words, in set builder notation, we define the set by stating the property of the elements in the set. Now, I'll write this down for you guys. So in set, now it might seem like something that you don't understand at first, but I'll try to explain it with an example. So in set builder notation, we define the set by stating the property of the elements. A very simple example would be, let's say, the set E such that it has n and okay. Now it might seem complicated at first, but let's try to understand what this means. We have already introduced this notation. This basically means that x is an element of the set n. Over here, this n represents the set of all natural numbers. So this is the set of all natural numbers. This single line that you see, it represents such that. And then you have the property written over here. That is x is even and x is less than 10. So I'll try to read this statement in one go so that it makes sense. It basically says that x is an element of natural numbers such that x is even and x is less than 10. That is basically how we do set builder notation. So as you can see, we define the set by stating the property of the elements. All these elements follow some very important two properties, right? One, they're all even. Second, they're all less than 10. And third, they're all natural numbers. So what would basically this be? It would basically be the set over here. All even numbers less than 10 would be 2, 4, 6, and 8, right? This is what E represents, but this over here would be the roster notation of it, and this over here would be the set builder notation of it, which is providing the property of how we write it down, right? I hope this makes sense. Now I'll be giving some questions on all these topics, right, so that it makes your understanding more clear. I'd like you guys to pause the video, solve all the questions, and then I'll cover them myself. And if you're able to cover it, then that's well and good, and that would be the end of the video. So I've given these questions on the board. Try to pause this video and solve them, and once you've done it, we'll start solving these questions. Okay, I hope you guys have solved all these questions. Now, let's start with the first question. It says, are the following sets equal or not? We have two sets, one which has these elements, 3 times 3, and then we have 2 and 1, and then 1, 3, 2. The answer to this question would simply be yes, they're both equal. Because remember the definition of a set. It basically means the order and multiplicity don't matter. As you can see, this set has different multiplicity of 3, and this set has different order. The only difference between them is different order and different multiplicity, but at the end of the day, both of them have same number of distinct elements and equal elements, which is 1, 3, and 2. That's why we can say both these sets are actually equal, right? So I hope that clears your understanding about the definition of what is a set. Moving on, we have another question that could clear your doubt. So which of these sets are same? We have set A, B, and C. Again, all these sets are actually equal, which is A equal B equal C. Why? Because if you try to remember the definition once again, order and multiplicity don't matter. The only difference between all of them is different order and different multiplicity. But end of the day, they're all equal to the set A, B, and C. So, which of these sets are same? All of them are actually equal. Moving on, let's try to understand question number 3. It says, let A be the set which contains the elements 1, 3, 5, and 7. Which of the following are true? So what do you guys think? What does this mean? This statement basically means 5 is an element of A. Do you guys think 5 is an element of A? We can see that it actually is. So this would be correct. Is 8 an element of A? We can see that 8, there's no element 8 inside the set A. So this would be false. And then we have, is 1 not an element of A? Is this true or not? Now, this is a tricky question. You usually get these type of questions in university exams. So it says, is 1 not an element of A? And we can see that it actually is an element. So this again would be false. So I hope you have a good understanding until question number 3. Moving on, which of the following is a finite set? Set A or set B? So set A, you can see it only has 3 elements, which is a finite number of elements, right? And we just know from the simple fact that this is actually the finite set. But do you think the set of all even numbers is finite or infinite? Now, try to basically understand it. We don't know where the even numbers end. It is actually endless, right? So there could be a very huge number which is also even, and there could be a very small number which could also be even, right? There could be negative number 2. So this set would actually be infinite, right? I hope you understand this question. Moving on, which of the following represents the empty set? Now, you're given 4 different options. So I hope you guys were right about this question. The correct answer to this question would be A and B. We covered it in this video. These are the 2 denotions that we use. Remember that these 2 are actually incorrect. This and this, they mean a set containing the empty set, and that's the same thing for this. So these are actually both equal. It's just a very important concept to understand. Again, you can be asked these type of tricky questions in your university exams, right? Moving on, let's try to understand question number 6. What is the cardinality of the following set? So this is again kind of a tricky question, but not that difficult, right? You're given a set, 1 occurs 3 times, then there's a 3, then there's a 4, then there's a 5. Remember the important part of what is a set. A set is a collection of objects where order and multiplicity don't matter. The very important thing for me to understand or solve for the cardinality of this is to write all the distinct elements in this set. The distinct elements would be 1, 3, 4, and 5. So the cardinality of this set will actually be 4. Why it would be 4? Because it has 4 distinct, or I should say unique elements inside it, right? I hope this question is clear. Now let's move on to the last question. Write the set of odd numbers in roster notation and set builder notation. I'll try to rephrase this question. Okay, so write the set of odd positive numbers less than 10 in roster notation and set builder notation. So we covered the similar concept at the very end of the video. So the roster notation is simply just representing it with curly braces and all the elements, which is, I should say, 1, 3, 5, 9. 1, 3, 5, 7, and 9. And the set builder notation of this would be, I'll just write it down over here. So I've written it down. X is the element of natural numbers. Now, odd positive numbers and natural numbers would basically kind of be the same set. So X is the element of natural numbers such that X is odd and X is less than 10, right? X over here represents all the elements which have the same property, which is they have 3 different properties. They're positive or part of natural numbers, they're odd, and they are less than 10. So I hope you were able to solve all these questions, and if you were, then that's a good start. In the next video, we will move on to a bit more complicated topics, but again, it would be easy and I'll again go slow and steady, right? So I hope you like this video. I'll see you guys in the next lecture.